session, and as you can see on my screen, it's another interesting topic we have today. It's one of those topics where you're going to learn something that probably you've not used, and more importantly, it will help you to expand your knowledge on the direction of how things are meant to go for those of us in the BI space. So today we have a special guest whom I'm going to do a more elaborate introduction of, and this session is brought to you by Your BizEdge and MHS Analytics. Your BizEdge is a Nigerian Microsoft platform-based analytics solution firm. We provide training and we provide consulting services, mostly to Nigerian clients and some few non-Nigerian clients. But MHS Analytics is our Canadian-based company, the same services, the same analytics services, but targeted at the North American market and also European market. So I see a lot more people are in, so this is perfect timing. And our speaker today, I forgot to let me quickly correct this. I have a template I use, so I think I didn't update properly that one. So good. So our speaker today is Dennis Torres. He's a DBA and data platform MVP who lives in Malta. He's a beyond being a Microsoft MVP. He's also someone who on Session 9, I think you won the award of the most active presenter for 2022. So he's someone who is, popular, who's presented on many global platforms. So we are honored to have him. He loves SQL. He's done software development for 20 years. And if you've not been to Malta, I'm sure when I read on his profile that he moved 10 years ago, he might not originally have had the mind to stay in Malta, you know, but Malta is enchanting. If you go there, you're gonna have some special feeling towards Malta that you probably won't go back or always want to come back to the place. So an honor to have him. I don't want to spend too much time reading his profile to us. I'm gonna share his LinkedIn link within the chat so you can connect with him. But right now, I'm going to hand over the stage to him so that we let him have all the time within the session to do what is prepared for us. So Denise, over to you. Yeah. So you can share your screen. I'll
Thank
stop
you.
sharing mine. Yes, sir. And just to mention, you can always put your questions in the chat. We are monitoring the chats. Thank you. Yes, Dennis, please.
Welcome, everyone. My name is Denis Torres, so I'll be talking about Power BI and Synapse, how they work very well together. So, this is me, Data Platform MVP, trainer, user group leader of Malta Data Platform Group, and you can see on the screen my contacts. It will be a pleasure to stay in contact. It will be a pleasure to connect on social media, so you can take a copy of this contact and connect later on social media. So, what's the agenda today? The title of this session seems a bit old, considering how Power BI is evolving into Microsoft Fabric and the Synapse Analytics from Azure is getting a bit old. So the title seems a bit old. Yes. But I can say that the only thing old on this session is the title. And I may improve this later. I will be talking about a bit about Synapse Analytics on Azure, and I will be talking a lot about Synapse on Fabric and how Power BI work greatly with both. So this is the agenda today, a quick review of Synapse Analytics, which Synapse Analytics I am talking about. I'll talk about the storage and Synapse serverless, access methods in Power BI, and Power BI aggregations, how this involves the usage of Synapse and how Synapse can help in both of these ones. So let's first make a quick review about Synapse Analytics, Azure Synapse Analytics. So, Synapse Analytics had a workspace on Azure and was capable to have on-demand SQL, a Synapse serverless which could access using SQL any set of files in blob storage in Azure Storage, a SQL dedicated pool, which was a massive parallel processing server working with SQL queries, a Spark environment, and more. More was being created at the time. And we use Synapse Studio in Azure to develop with all these tools. And Synapse Studio was integrated with Azure Data Factory. It became Synapse Data Factory with Power BI and Power BI. It's like if Microsoft were getting all these old tools from the 80s and joined them together in a single tool. Microsoft was getting all the old tools and joined them together, like a switchblade, a tool capable to do everything in a single place. And I confess, at the time it was difficult to imagine it could become better, but it did. It became way better. So, which Synapse we are talking about? So, I'll talk mostly about Synapse Serverless. The examples that I will make are related to Synapse Serverless. And I'll talk about Fabric Synapse because now the new Synapse is inside Microsoft Fabric. Okay, Fabric is not GA. I'm talking about a preview product. Yes, true. It's true. I'll be talking about a preview product. But it doesn't work to talk about Synapse dedicated pool. Doesn't make sense because Synapse dedicated pool is expensive. No one will start a new project in a Synapse dedicated pool at this moment when you have Synapse inside Fabric, which is way better. The Spark pool on Synapse, the same. You have Spark inside Microsoft Fabric Synapse, so you don't need to use Synapse Spark pool on Azure. The same. What Fabric doesn't have, what Microsoft Fabric doesn't have yet, is Synapse Serverless. Microsoft Microsoft Fabric doesn't have a tool which directly compares to Synapse Serverless. So Synapse Serverless may survive for quite some time, even while we are already using Microsoft Fabric. So the Synapse Serverless may continue for a while. Besides that, the Synapse Serverless is also the best migration point between the old times, the work with Azure Synapse, the work with Data Factory, the work with Spark, and the new times, the Microsoft Fabric, which is still in preview, is not GA yet. So how do you make a project now? Synapse Serverless is the best point of migration. It's easy to build something now using Synapse Serverless and then migrate later to Microsoft Fabric. Let's talk about data platform architecture. Let's start with the very old ways, a classic design of a data platform solution. We have data sources, many data sources. What we do with these data sources inside an enterprise environment? We integrate them. So we use an ETL process to organize this data, clean this data, and put this data inside another storage. The model which is used in production environment for the data sources, usually doesn't mind about history, while data specialists knows that they need to mind about the history of the data. So the model a lot of time needs to be fixed between the production and this storage. You are reading data warehouse. Oh, is data warehouse something actual, something current, or is this some old thing? A lot of people use lake houses at the moment. Yes, but doesn't mind. Data warehouse, lake house, doesn't mind. There is small difference in relation to the technology. Doesn't affect the main architecture. So after you have your data on this storage, you will start to publish your data to end users. But this storage usually has a format that is not easy for end users to follow, not easy for end users to query the model that you use on this storage, besides the lot of history you have on this storage. So what you do? You create a data model. This had many names in the past. The most common names was called cube. We're used to call this a cube because the format, how it could allow the user to see the facts of the company using different dimensions and rotating the dimensions to see the factors from different points of view, from different angles. So these were usually called cube. But another very common name was semantic model. A lot of people call this semantic model exactly because we got our storage made to be a historical storage for the company and made it more accessible for end users. A storage easier to be queried by end users, easier to be understood by end user. Of course, in the middle of this process, a lot of history would be kept only on the main storage. The data models would answer the main concerns for the users. Sometimes once in a year, once in a month, the user may make a question that the semantic models would not be capable to answer, and they would need to query the main storage. And to show all this information, we have the reporting and analysis tools. Get data mainly from the data models, from the semantic models, and sometimes getting data directly from the main storage and generating many reportings, dashboard analysis, and so on. So about the name, data warehouse, data lake, lake house, what's the matter of this name? These are small technology difference between data warehouse, data lake house. There are specific technologies, the specific requirements that will make you choose one or another. But the point is that main storage we are talking about, whatever of these names you use for it, it's a single source of truth. This is an architecture intended to have a single source of truth, which can be a data warehouse, which can be a data lake, a lake house, whatever name you use according to your needs in relation to the technology. Maybe some of you may have been studying architectures and heard about some new architecture. So if some of you heard about some other different architecture, I would like to drop a line of thought, but I will not dig deeper on this. A different architecture is called data mesh. But there is a lot of people that keep thinking that data mesh is the opposite of a single source of truth. No, single source of truth is not good anymore. Now we use data mesh. That's not true. Data mesh doesn't replace single source of truth, it expands it. It expands to a level that we start working with multiple single source of truth. In a close future, maybe in some weeks in the future, I'll be publishing a video about data mesh in Microsoft Fabric, but this is not the subject of this session. I would like to just drop this message here. Uh, if anyone already heard about single source of truth and data mesh, to bring this thought in mind. So where Power BI fits in on this architecture, classical architecture that I just illustrated. So when Power BI was born, Power BI got the area of reporting and data models. Power BI was never completely capable to make the work of a single source of truth, make the work of a data warehouse or a lake house. Were never capable of that. And exactly because that, in all sessions I delivered as an introduction to Power BI, I always said, never use Power BI to get data from production. It will end up in a mess. You need to have a central storage, a central data intelligence storage, either data house, lake house, or whatever you need. And Power BI will get its data from this historical storage, not from production. You need to prepare this storage first to feed Power BI. So this preparation here is enterprise, what we could call enterprise ETL. I mean, it would be a group of data engineers in the company that would do this preparation, prepare a data warehouse or data lake house for the company. But Power BI is considered a self-service ETL tool. What this means? This means that any department can use Power BI to get the data from the central points where the company is storing its historical data. Sometimes merge this data with local data that the department has and generate reports. So this is where Power BI were used to fit when Power BI was created. Okay, but now it's not Power BI anymore. It's Fabric. So Power BI is becoming Fabric. The portal is becoming Fabric portal. Everything is becoming about Microsoft Fabric and not Power BI anymore. So it's not Power BI anymore, it's Microsoft Fabric. Everything is becoming Microsoft Fabric. And what happens? It got everything. It got all the process for the enterprise data architecture. All the process is covered by Microsoft Fabric. How this process is covered? The enterprise ETL can be made using pipelines that comes from the Azure Data Factory, which now works inside Microsoft Fabric, using the data flows generation 2, an evolution of the Power BI data flows, or notebooks, Spark notebooks that we can run inside the, let's call, Fabric environment. Now it's Microsoft Fabric environment. The central repository can be a data warehouse, can be a lake house, or can be a custom database. It doesn't mind. We can choose any one of these storage, use this storage with Fabric. Fabric has all three. And in fact, all three underline all this storage. There is one central storage called One Lake. So everything is stored in the same place. And this is what is called now Synapse. You see the name Synapse many times inside the Microsoft Fabric portal. This database, the data warehouse and the lake house, are considered the Synapse inside the Microsoft Fabric environment. Is the evolution of the Azure Synapse. And we can build architecture, more complex architectures like medallion architecture inside the Microsoft Fabric. This doesn't replace in any moment the other two that I mentioned, single source of truth or data mesh. The medallion architecture is used to improve the quality of the data. So you can build the medallion architecture at this point. We had the data set. Power BI had taken that piece of the architecture, and what was cube was being called data set. But exactly some days ago, it was what? 2 days ago, more or less? Yes, about 2 days ago, Microsoft decided there is no more data set. We will not call them data set anymore. Now they are called semantic models. So we got back to the classic architecture of a data intelligence environment. The data sets are now the semantic models, are called the semantic models. The data marts can be considered semantic models as well, part of the semantic model as well. It's not clear what's the future of the data marts. If Microsoft will keep the data marts together to work together the semantic models in a self-service environment, if the data marts will end up dying. Remind what I said before. I said the model inside this storage, the central storage, is not always user-friendly. The model in this central storage is intended to contain the entire history of the company. And then from this model, you build semantic models, small dedicated semantic models for a specific purpose, intended to be more user-friendly. These semantic models are intended to be user-friendly. These were the ones that you call data sets just a few days ago, and Microsoft just renamed them. And at this point, between the data warehouse, the semantic model, and the reporting is where self-service CTL is located. Our end users continue with the possibility to use Power Query to make self-service ETL. Make self-service ETL consuming data from the work produced by the enterprise data team from the company, which is the single source of truth. It's a bit more complex if it is data mesh, but I will not get so much in details about that. That's the idea of Microsoft Fabric and the current architecture that we have that is completely taken by, let's say, the old Power BI, which is now called Microsoft Fabric. The name Power BI still appears in some place. I can bet the name Power BI will be slowly replaced, completely replaced by Microsoft Fabric. So, I said the serverless Synapse pool is a feature that Fabric doesn't have yet. Fabric doesn't have the ability to read data from Azure storage. It can't read data directly from Azure storage. Not any data. It can read Parquet data, or we can build a notebook to transform some data, but not with SQL queries like the serverless pool were capable to do. So what I will illustrate in a comparison between Power BI and the Synapse serverless SQL pool is that the purpose of this demonstration that I'll do now is that only because you have a connector doesn't mean that you should this connector should be your first choice. You need to think very carefully about what connector you use. And what Power BI isn't. Power BI isn't a big data processing tool. Power BI has connectors to connect to storage, to Azure Data Lake Storage. Power BI can connect to Azure Data Lake Storage, but Power BI isn't a data lake processing tool, so it will never do so good work connecting to a data lake storage as a big data processing tool can do, like Synapse Serverless. What I'm calling big data storage. In a big data storage, each folder should behave as a table. We store in the folder many files, and those files should be treated together as a single table. The big data processing tools already know that and join the files, the multiple files, and treat them as a single file for us. So big data tools are optimized to read this data. Power BI is not directly optimized to read that. Power BI can use Power Query to read an Azure Data Lake Storage version 2. But it has user interface functions to process the files in a folder. The responsibility of process the files becomes Power BI responsibility, and it puts on Power Query a coding responsibility. We can see the code happening on the Power BI side, while in serverless SQL pool, for example, the work is for the serverless SQL pool. We send the query and give us the result, just that. So let me show an example before we continue. Let me jump in a demonstration before we continue. Okay. So I have here an Azure environment. I have a storage called Lake Demo. Inside this storage lake demo, I have many containers. I have a container called Open Data Lake. And here in this container, Open Data Lake, I have a container called trips big one. And inside this trips big one, I have 5 Parquet files. Each one has more than 100 megabytes of size. And I built 2 examples of Power BI reading this data. On one example, I used the storage connector connecting to the storage, while on the other example, which is this one, instead of connecting to the storage, I connected to a Synapse serverless and did a SQL query on the Synapse serverless. Let's understand the difference and compare the result. Let's go and edit the query. First for the storage. So I have a trip query. This trip query, the source is that folder on the storage, and it reads the files one by one. So it becomes responsibility of Power Query to process and merge these files. So the connector creates the functions to process the files automatically. These functions were created by the connector, but it created these functions automatically. So the connector created these functions automatically for us. Okay, and how does this work on the Synapse serverless example? On the Synapse serverless example, connecting to a Synapse serverless, edit query, I have the trips query, and if I open this data source, is a select query. I'm just sending a select query to a Synapse serverless environment, and the Synapse serverless is the responsible to get the data for me. So the responsibility to join the content of the file is not a Power BI responsibility. It becomes a responsibility of the Synapse serverless. Okay, what difference this can cause? Well, some obvious difference you may be noticing here is the difference on the amount of code the Power Query is executing to reach the final result. This is an obvious difference here, but to check in more details the difference, let's start the diagnostics and ask a refresh all. It's refreshing out the data for us. It will take some moments and okay, done. I can go back to tools, stop diagnostics, and then I can see the diagnostics information here. And I can check the duration of this execution. This execution went from 18 hours, 35 minutes, and 21 seconds to 18 hours, 35 minutes, and 50 seconds. So 29 seconds is the total duration of this query, exactly, until 50 seconds. So it took 29 seconds. This is the storage example. Let's check now the Synapse serverless example. I'll do the same. I'll start the diagnostics, go back to home, and ask refresh all.
Dennis, so there's
Yes?
a suggestion someone asked. So I guess because of the your resolution of your laptop you're using, I'm sure you're using a very high-end laptop. They're asking if there's a way you can increase the zoom so they can see the text more. It's just a suggestion if it's possible.
Yes, totally possible. It's just that I didn't notice something more important to zoom. But this select is an example here. So you could see the select used for the Synapse serverless. So if there is any other point where you would like to zoom and I forget, please advise me. Let
Okay,
me
thank
stop
you.
the diagnostics. Yes, so I will look to the aggregated information and you can see it took from 3711 to 3730. It took 10, 19 seconds. 19 seconds, 10 seconds less. 10 seconds less than the example with the storage. 10 seconds less. 10 seconds is the user waiting to see a visual is something. And it also depends on the amount of information, caching, all the details. Okay, so we see the performance. The performance of the Synapse serverless query is way better than reading directly the storage. So the serverless is still very useful for us. It was always very useful for us and is still very useful for us. So I started this part of the demonstration highlighting that just because you have a connector doesn't mean that you should use that connector, that is the best connection for the situation. Like here, the data is on Azure Data Lake Storage. There is a Power BI connector to Azure Data Lake Storage. Is this the better? No, because Power BI is not a big data processing tool. Synapse Serverless is. Synapse Serverless can read that data. Or nowadays, we can read that data with Fabric as well. There are many different ways to read that data with Fabric. Okay, so getting back to the slides, I was highlighting the different behaviors and how it creates, when accessing the storage, it creates functions for us to deal with each file, handle each file. This is the M code of the function. The M code of the function to deal with each one of the, no, this is the main function that makes an invoke function to deal with each file. For each file, For each file, call the function transform file with the content. Okay. So Power BI making a loop over the files. That's what Power BI was doing. And with Synapse Serverless, this was not needed. That's the first demonstration we saw. Now let's talk more about Power BI in Fabric Access methods. Before I get deeper on how they both can work greatly together, let's first have an explanation about the access methods. What are the access methods? We can access a source using the import method, direct query method, live method, or direct lake method. So these are what we can call now 4 methods to access a data source. And as a bonus, we can create what are called composite models. We are creating a composite model when we mix these methods. The methods that we can mix are import and direct query. Live and direct lake are impossible to mix. So we can mix import and direct query methods in a single model, creating a composite model. So, import model. What is the import model? We have the data on the server, and we have our query in Power BI. So the import model is when the data goes to Power BI. And Power BI depends on its memory to process the data. So in this slide, the message is highlighting the space in memory on the Power BI side. Yes, it's highlighting this point. But there are other details about the import method. For example, is the one that provides the best performance possible. The import method has the best performance possible of all the methods, because the information will be on the Power BI memory. But since the data is on the Power BI memory, it means this data needs to be refreshed from time to time. That's when we need to make the data set refresh and schedule the data set refresh for the import method. Okay. And the direct query. The direct query is the opposite, is when the query goes to the source to execute using the resources of the source and get to Power BI only the result of the query. Usually this works well when the amount of data is too much to be put in memory of Power BI, but it's slower because it depends on the communication between Power BI and the source. So this ends up being slower than the import method. Direct query ends up being slower. But with Fabric and the creation of the one lake, we got an additional method. We got an additional method on now this, which is the direct lake. So you are seeing here, the import method is when your query, the result of your query goes to the memory of the Power BI environment. The direct query method is when your query goes to the source to be executed and show the results of the source in, say, real time. Doesn't need refreshes of the data set like the import. But now with the one lake, and Microsoft Fabric, we have what's called direct lake. Using the direct lake method, the query comes from Power BI and goes directly to the one lake. There is no middleman here. On the other ones, there is a middleman to process your query. There is a middleman to make a processing of your query. Direct Lake doesn't use a middleman to process your query. And we need also to talk about lakehouse access methods. There is the live method. What is the live method? The live method that we talked before is when we connect directly to the default data set of a lakehouse or a data warehouse. You may remind that these objects create a default data set. When you connect directly to this default data set, you are using the live method. When you use a data set connected to the default data set is direct query. Why would you do that? Because the live method is restricted. It doesn't allow you to mix, for example, data from two different sources. You can't get two different sources and mix. No, it's live to one source and use the direct link, the best method possible in relation to performance, and use one source. If you want to mix data from multiple sources, you need to have your own data set. Then you'll be using your own data set connected to the default data set to the lakehouse using direct query to this default data set. Or the lakehouse has another access method. Instead of accessing the default data set, you can access a SQL endpoint using direct query. So you can access the lakehouse using the default data set of the lakehouse, or you can access a lakehouse using the SQL endpoint of the lakehouse, using direct query to the SQL endpoint, or import to the SQL endpoint. That's interesting because the other methods don't support import very well, but the SQL endpoint supports the import method, and the import method is great in relation to performance. Let's illustrate this because I talked about a lot of complex concept. Let's illustrate this concept. So I have here a lake house. This lake house is called Malta Lake and has some tables here. I'll be mostly using the dimension city table and the fact sale table on this lake house. Mostly these two tables. So let me open again here, another window. Let's take a look on the workspace called Malta Fabric Demo. Yes, there is a lot here. Let's see only the semantic models and the lake house. So the lake house that I'm using, you saw it's called Malta Lake. Yes, the lake house I'm using is called Malta Lake. And we have The Malta lake house is created here. The Malta lake house is created here. And the Malta Lake semantic model. See how the data set is already renamed as semantic model. So for every lake house, a default data set, which is now a default semantic model, is created for that lake house. And let me show as well the SQL Analytics endpoint to illustrate the point that I'm trying to show. So for the lake house, we have a default semantic model, and we have a SQL Analytics endpoint. So what am I illustrating with this? I'm illustrating some points which I mentioned on a previous slide. That to connect to a lakehouse, I can connect to the default data set, or I can connect to the SQL endpoint. There are two methods to connect to the lakehouse. Two methods, two main methods, and then we broke them down. Um, so it was mentioned that the owner is different. One, the owner of the lake house is the user, and the owner of the semantic model and SQL Analytics endpoint is the workspace. I confess I had not noticed the difference of the owner, but it has a meaning. The meaning is that the lakehouse is the object that is created directly by the user. What the user creates is a lakehouse. The SQL Analytics endpoint and the full data set for the lakehouse, they go together the lakehouse, but they are created automatically by the environment. Uh, and the SQL Analytics endpoint and the semantic model use refresh, not a refresh that we need to do, refresh that are done automatically, if almost on minute level, if I'm not mistaken. But there is a level of refresh that is done here. But the lakehouse, the information is inserted into the lakehouse according my ETL, according my pipelines, according my notebooks. There is no specific refresh date for the lakehouse. It's my ETL environment that gets information and puts information inside the lakehouse. Okay, so this illustrates a bit the details of the connections that I was mentioning. I will show visually how these connections are made, but I have examples of them already made to don't take too much time. If you haven't seen before, the Power BI desktop is with the same view than the portal. This is in preview. You need to enable this view. You need to enable this portal view on Power BI desktop. So I go on Power BI desktop and go get data from a lakehouse. I want to get data from a lakehouse. I choose the lakehouse and look at the connect button. There is this arrow close to the connect button. If I go and don't look to the arrow, I directly click connect. To what I'm connecting? I'm connecting to the default data set of the lakehouse. Or the full semantic model of the lakehouse. So I'll be connecting to the default semantic model. But if I check the arrow, I see that I have a second option. The second option is to make a connection to the SQL endpoint of the lakehouse. So these are two options to connect to a lakehouse. Connect to the full semantic model and connect to the SQL endpoint. Um, I'll give you half of the answer. There is a question here. Emma made a question about when I consider useful to connect to the default data set. Because to connect to the SQL endpoint is always better. Okay. The default data set is intended to keep the model that I created for the lakehouse. So the model that I created to the lakehouse is intended to be kept on the default data set. Some measures that I create, if I already go to the lakehouse and create measures, they will be on the default data set. This makes it useful. But there are more reasons that I will illustrate. If they are not well explained, get me back with this question later. So now let's compare these access methods. First is the access that I call Lakehouse Live. What is this? This access is when I connected to the default data set and just that. Is a live connection to the default data set. I said this live connection has restrictions. I cannot use get date and try to get other things because it would fail. If I try, it would fail. Uh, to be able to merge data from multiple data sources, I would need to transform this, creating a local data set. There is a button in the model on Power BI Desktop called Make Change to this model. So, make change to this model. What this means? This means that instead of live connection, I'll be changing the live connection to a connection that has a local data set and will be connecting to the remote, the full data set of the lakehouse. Uh, Getting back to the slides to review what I said before, I said you can make a live connection to the default data set, or you can make a data set connection to the default data set. That's what I'm highlighting on the tool now. And let's see the results of the live connection. How can I see the results on the live connections? I can use the performance analyzer to see what performance this live connection provides to us. So I start recording and refresh our visuals to check the performance. $11,944. Uh, probably, probably there is a small problem of caching that the lake house was sleeping because I was not querying it for an hour or more. Probably there was this problem. But one point is that I have the DEX query and then directly the visual display. Let's see how this is different when I get a different method of access. On this one, I created a local data set. I have done anything. I haven't done anything with this local data set. I just clicked the button and the button disappeared. I already created a local data set for this guy. So this is a data set, a local data set accessing the default data set of the lakehouse. So I'll go to optimize, performance analyzer, start recording, and refresh visuals. It shows 642. But here you see an element that it was not here before, an element called direct query. This means this one is using direct query, while the live connection, when I use live connection, there is no direct query. The DEX query is directly executed on the lakehouse. Let me stop the recording, start the recording again, and refresh the visuals again to get another result. It's a failure of demonstration because the intention was to demonstrate that the direct lake is faster than the direct query, although I end up showing the opposite result. So it's a failure of demonstration because many caching features that exist between both. Then end up the direct lake with 652 and one step less. There is no the direct query step. There is one less middleman in relation to this. There is one less middleman. The direct query middleman doesn't exist when we make the direct lake. But the direct lake only exists on the live connection. We can't combine any other data source. We are very limited on that. The direct lake is only happening when we make a live connection. Okay, so we saw both connections related to the full data set. Both connections related to the default data set. And how is the connection to the SQL endpoint? Let's see an example with the connection with the SQL endpoint. Is this connection that I'm calling direct query. In this connection, I made the connection using the SQL endpoint. Instead of using the default dataset, I use the SQL endpoint. Let's start recording and make a refresh of the values. $8,200 and something going directly to the SQL endpoint. Let's make more than once just to double check. So it reaches 1,250. What would be expected? What would be the most natural result? It would be the SQL endpoint has a slower performance. The SQL endpoint is slower than the live connection because the live connection is using direct lake. So it's lower than the live connection, but it's faster than dataset to dataset connection. It should be a bit faster than this one, dataset to dataset connection. But in the end, the demonstration ends up showing that it depends a lot on the environment because there are many caching levels on this environment, so it's difficult to predict in many situations what you get in every situation. But these are the connections, the main connections. So live to the default dataset to the default dataset, SQL endpoint with direct query. But using the SQL endpoint, I can make an import. But I left this for last because this is a scenario that we can make Power BI features and Synapse features. I'm talking about the Synapse of Synapse inside Microsoft Fabric. The Synapse features inside Microsoft Fabric. And we can make them work together generating aggregations. What are the aggregations? Imagine that I have the table trip. These are the taxi trips in New York during a period of time. This table is intended to be huge. Is it needed to know the details of each one of the trips? Probably not. Probably not. For analytical purpose, there are many ways to aggregate the data and still have the analytical information. For example, how many trips happen by month? For example, it's an example of an aggregation and it still have the information. So we can create a table which is an aggregation of the main details table. So we may need an ETL process to keep this aggregated table updated. This is possible. You keep an aggregated table updated with an ETL process, unless you use a view to create this aggregated table. You can use a view to create this aggregated table and it still works. And we can configure the aggregations in Power BI. What this means, configure the aggregations in Power BI? Imagine that you have the details table and the aggregations table. You have the two tables. What we will do? We will choose what visuals you put on the details table and what visuals you put on the aggregated table. Well, the idea of Power BI since the beginning, and this is a lot of time ago, was that Power BI would decide this for you. So you would point to Power BI which ones were aggregated tables, and Power BI would decide to you when to go to the aggregated tables and when not to go to aggregated tables. Let's go directly to an example about this. This Power BI is using the SQL endpoint to get data, is using the SQL endpoint and the model gets the tables using direct query. But I'll get one more information from the data lake. I'll get one more information because I created in the data lake a view called state grouping. I'm grouping the sales, the fact sales information by state and getting a total of the number of sales by state. So what I'll do, I will get the data from the lakehouse, Malta Lake. I'll choose to connect using the SQL endpoint. and I'll get this state grouping view which I created and load this view in my model. It will ask, how would you like to load this view, using import or direct query? It only asks this if I'm using the SQL endpoint. If I use the full data set, it doesn't ask. It's always direct query. So on the SQL endpoint, I can use import mode because an aggregated table is usually small, so I can import. So I make this table an import table. Okay. The table appears here, but that's not the intention. It's not the intention that the table appears there. What I'll do, see, first we notice the difference on the models. The blue line indicates that this table is using direct query. The lack of the blue line indicates this table use import. One table use import, another using direct query. I right click and select manage aggregations. I will tell that this table state grouping is an aggregation. Aggregation of what on what table? Is a group by of the state province field located in dimension city in state province field, and the total is a count of the orders. And to point to that, I'll point to the primary key of the order, sales key, and apply. The table is immediately hidden. Power BI will decide by itself when it should use the aggregation. So let's test again the performance. Let's go to the performance analyzer, start recording, and refresh the visuals. 103. Is faster even than the direct link. Using aggregations is faster even than the direct link. So you have a tough decision. Direct link is faster than direct query with SQL endpoint, or should be faster than the direct query with SQL endpoint. But if you use direct query with SQL endpoint and use aggregations together, you may have a faster solution even than the direct link. So it's a way to combine the power of these solutions. Let me copy the query and show the resulting query on Notepad. Showing the resulting query, although it doesn't show immediately how it is going to the aggregation, I would need to use another tool to double check that it's using the aggregation. I was intending to show that it was going to the aggregation, the count of the sales key, but summarize columns from dimension city, state, province, but only the timing is showing that. Only the timing 103 is showing that is going to the aggregations. And then is becoming even faster than direct link if you made the correct combination with the aggregations. Okay, so reviewing the methods, live to the full data set using direct lake. Data set to the default data set. Use direct query. SQL endpoint using direct query or SQL endpoint using import, and mixing direct query with import on the SQL endpoint. You can use the Power BI aggregation feature, and using the Power BI aggregation feature is even faster than direct lake. Of course, it will depend on the amount of data you have, but usually it's even faster than the direct lake. The managed aggregation that I show you in a different example, okay, configuring the aggregations, and we saw the example with the aggregated views. So that's it. My contacts are on the screen. Any questions, anything you would like to ask?
That's that's a lot of stuff you covered for us in 1 hour. Uh, Thanks a lot.
Yes, so sorry that I got way beyond 1 hour, but
No, no, we enjoyed it. Like I said, also the session is being recorded. So I noticed some people, because of other agenda, they could not stay to the end. So they always are aware that it's being recorded. I will even share to the entire house how they can access the links. So we've got to that point where you can ask questions. So, and I think I even have a question. So, Dennis, it would be nice to hear your journey, how you transitioned. I think you used to be in software development, then you moved into database proper, and now you added Power BI. So I want to ask, can you tell us your interesting journey so we get to take some inspiration and got to know how much we need to do to get to where you are?
it's not easy to say. It's difficult to say because I work with technology since I was. You can imagine. I have 46 years old today. I work with technology since I was 11. At that time, that old time, it was easy to focus even not on two, but on three areas: infrastructure, database, and software development. I like it to focus on the three areas. Then, when the year 2000 came, Microsoft released everything together: Windows 2000, SQL Server 2000, and .NET. Then I had to choose and at least drop one. So I dropped the infrastructure. And I stopped following infrastructure after that. Then I kept following software development and data platform. And what happened is that in different periods of my life, I had focused on one because of the work. I was working as a software developer, or I was working in a project involving a data warehouse. And each period of the life aggregated something that keeps in my mind and relates to the technology. It's interesting how 2 weeks ago, if I showed anyone this graphic, it would be seems a very old classical architecture. But now Microsoft renamed the datasets to become semantic models, and became clear that the path of Microsoft Fabric was exactly to return to that old architecture. It took us there, just with new names on the features. So each period of experience that you have will help you further on your technology learning. Even if you think, oh, this technology will die, but you keep some experience from it that you use it later.
Oh, I like that. I like that. The fact that uh, you don't try to game what is, because some of us, we are always trying to game like what's going to be the future, what's lets me drop this, pick that. For you, you see that at the bottom there's this consistent, should I say architecture? I think you called it architecture the other time. That the architecture doesn't really change much. The tools, the way, the technology, the names, the maybe a little addition to something here and there, but overall, what the
The
goal
needs
is.
and the requirements become the same, so we need a
Yeah.
similar architecture with different tools and different names.
Yes, I like that approach. Wow. So one more question. I'm also trying to check if others have questions. It's what advice do you have for people starting out now? So I'm going to try to give a context to who most of our audiences are. So we have a larger chunk of us. No, not all of us are like Hammond. Hammond doesn't look like the typical audience. He seems advanced already in this journey. But most of the audiences we have in this group and those who will watch the recording, there are people who they're just starting their journey. Many of us are not in an environment that affords us the ability to see, a proper enterprise ETL, see all of these uh, options that exist and probably what the best approach should be. Some of us work, you know, some are learning, we're learning by ourselves, and so it's just what we can access. And understandably, we cannot access very expensive software, and sometimes we don't even know they exist. And then some other people are working with small organizations where, again, they might not know that there are other tools that exist. So my question to you is, what practical advice do you have for people starting out and people who don't have this broad view of, what things should be like?
Well, my advice would be to go to the root of all this. Find the root of all this and understand the root. Once you understand the root, you understand how each technology is feeling that root, and you will be able even to tell when something is not so good because you understood the basic concepts. What I'm talking about, the root of all this. Data house is considered to have two fathers. One of them, that was when I learned data house, was Imon, that W.H. Himon. And he has a book explaining the concepts of data house from the beginning. So my recommendation would be to take a good weekend, turn off everything, turn off the cell phone, get a book of the root concept of the thing, and go deep on the root concept of the thing. Once you understand the why is this needed? Why does this happen? Why this situation is needed? It will be easier to understand what the technology is doing and even understanding when a company is not using it well. And it happens a lot.
Oh, thank you. Now that you mentioned him on, there's another one that usually, come up when I'm speaking with companies and even sometimes in interviews. That's also Kimball, Ralph Kimball. And most of us used to think of them as like options, like one is like Apple, the other one is like Android, one is like, Mac, the other one is like Windows. We always used to think that they're telling us different things, you know. I don't know if you also have any advice on how should we also consider Kimball? Should we also
My recommendation would be to read both. Read
both?
both.
Okay.
Kimball and Emo. Read both. Emo has a theory that everything should be built together, and he explained this theory on his book. Because if you build piece by piece, is like is like a lot of pieces that will not fit together when you try to join them. Is his explanation on his book. While Kimball goes to a more practical approach because Kimball uh, explains that it's impossible to build everything together in a huge corporation. In a huge corporation, it's impossible to build everything together. You need to focus on piece by piece, on each piece in an isolated way. In fact, this mix between Kimball, it's interesting because this it just came to my mind that this mix between Kimball and Imon is reflecting on the single source of truth or the use of data mesh. Data mesh is way more recent than the single source of truth, but it reflects. It's like it's one is Imon approach and the other is Kimball approach, but they not replace each other. They end up working together. This would require an entire other section to explain.
Wow. Wow. Thanks. Any more questions from anyone in the house before we left? We let Dennis go. It's been a wonderful one. Going one, going two. Okay. In that case, maybe I sneak in one more. And so the question I will just sneak in is, uh, if I don't expect it, but what made you stay in Malta? Why did you choose to stay in Malta?
Um, the fact why I arrived in Malta was mostly by accident. I was in Brazil. I was trying to go to Australia and have some problems with visa because especially because my age and the opportunity in Malta period. So why I arrived, it was mostly by accident. But why I stayed in Malta? My hobby is snorkeling, and I'm on an island, so
Wow.
it's great. It's great that I love snorkeling, and I'm on an island. The weather here is
Perfect all
similar
year
to the
round.
weather in Brazil than other places here. It's more difficult to find other place in Europe that has a similar weather than Brazil. And Malta sets English as one of the official language. So this avoids me the need to really learn a completely different language. I could focus
Wow.
on the English. I was
Wow.
a public speaker already when I came, so I could totally focus on English
Wow.
and not bother with another language.
Wow. Wow. Wow, it's amazing. So, do you have any sessions on? I know you're popular on SQL Saturday. Do you have any sessions that you're going to be doing that you want to invite us to join, so I can tell the whole house? We can put a link for them to sign up.
Online, I don't have any schedule to be online, but
Oh,
I'm releasing a video about Microsoft Fabric every Monday on my YouTube channel.
oh, please let's share that. Let me look for the link. I don't know if you gave us the YouTube link. Oh, you gave us Dennis Torres. Let me
Yes,
get it.
the YouTube channel. Every
Uh,
Monday, I share a video about Microsoft Fabric on my YouTube channel. And the next sessions that I'll be delivering will be in-person sessions. One is totally confirmed. It will be on November 18 in Parma, north of Italy. The other one is not confirmed yet. It may or may not happen in Rome.
Oh, wow. So I'm sharing your YouTube channel.
Thank you very much. And in
Yeah.
fact, I have a list of 2 or 3 videos of sessions that I delivered that I need to edit and publish it to the YouTube channel.
Oh,
Soon. That's why I said soon. In some weeks, I'll be publishing a video about a data mesh in my YouTube
yes.
channel,
Oh,
about
wow.
Fabric
Great.
and data mesh on my YouTube channel.
Okay. So I think with this, we have come to the end. Thank you, everyone. And thank you very, very much, Dennis. Grazie, obrigado, right? I think that's how I say
Yes,
thank you in Portuguese,
correct,
obrigado.
correct.
Thank you very, very much.
Correct.
And
Thank you very much. It was a
yes, we,
pleasure to deliver the session. Thank you very much.
uh,
Uh, it's a pleasure to see that you all enjoy the session. Thank you.
yes, yes, thank you. So the video recording will be live tomorrow. I've shared the of this session. So thank you everyone and have a wonderful week ahead. Thank you once again, Dennis. And bye to everyone. Thank you. See you
So
next
this
week.
is the YouTube channel where the video will be, right?
Yes, yes, the
I will
video
take
of
a
the
look there.
recording. Thank you very much too.
Thank
Bye
you very
everyone.
much.
Yes.
Bye.
Bye.
Have a nice end of weekend. Bye.